a quadratic expression with two logarithmic roots, and it's base 10. So in other words, I'm going to write down what one of these means. Log 10 of a quantity squared minus 30 times log base 10 of a plus 36 is equal to 0. And similarly for log base 10 of b. So again, log base 10 of a and log base 10 of b are roots. And I've written down what it means for log base 10 of a to be a root. And again, similar statement for log base 10 of b. Now, another thing that's important here as far as trying to find what we're looking for, which looks like a change of base circumstance here, is that if you have quadratic expression with two roots, we'll call them r sub 1 and r sub 2, and you expand this out. And again, practice competitors know that this is just the justification for Vietas. But when you expand this out, you get x squared, and then minus the sum of the roots present as the coefficient of x. And also just the straight up product is your last term. The minus signs cancel out. And so the product of the roots appear as the constant. Okay, those two results, or this is an important result because what we can do very quickly is write down log 10 of a plus log base 10 again, I'm just including it here for the heck of it, okay, is equal to 30. Now it's slightly confusing, but remember it's minus the sum of the roots present as the coefficient of x. Well, minus a minus 30 is just plus 30 right here, and I'll put that parenthesis, that's plus 30. Okay, now this very next step here is just the change of base formula. Since these are base 10 logarithms, we will go ahead and write down a base 10 change of base here. See how we have log base 10 of b over log base 10 of a, and then conversely right over here. Now this part is just basic algebra, very rudimentary algebra right here. And we know that the product is 30. We have that right here. I didn't write that down. But the product of these guys is 36. Remember right here it says the products of the roots. This is the product. That would be 36 as far as the given logarithms. All right. And then this piece right here is just remembering to substitute back in. Now, probably you could do some other type of algebra, but remember how I wrote log base a squared of all this equals to 0? Well, you can rewrite each of these squares like this, okay? You can rewrite each of these squares exactly like this based on the fact that each of them are actually roots of the quadratic. Okay, and the rest of this is just collecting terms, getting everything together. Let's see, this would write, you have the sum again, which we know to be 30. So right here you would have this is equal to 30 squared over 36 minus 2, it looks like. All right, folks, is that right? 30 squared over 36 minus 2, whatever that's equal to. I'm tempted just to leave it that way. Log of a plus b is 30. You have 30 squared right here, minus 2. I'm trying to think of a way to get this to simplify. 30, maybe it'd be easier just to write it like this. 30 over 36 times 30. Yeah, this might be easier. Minus 2. Yeah, okay, that looks like it may simplify a little bit easier, because this would be the same thing as 5 over 6. 5 over 6, that'll cancel 5. And so, y'all, I'm getting 23 out of this. Let me know if I'm making mistakes on the arithmetic. But I think perhaps this is the simplest algebra here. Okay. So you see, this is 5 over 6 right here. So that would be 5 times 5 is 25 minus 2 is 23 is what I'm getting. Let me know if I made a mistake on the arithmetic, but I think that's right. And so we know that without actually knowing the values of the individual logarithms, we know that this is equal to 23. And again, notice we never solve for A or B. I'm not sure if we can, really. Okay, but this is the answer I got, y'all, 23. Let me know if that's, I think I approached it correctly, and I think that's the correct answer, but let me know if you catch any mistakes in the arithmetic or just the overall approach. Okay, thanks for viewing.